Massive dark star, 88 times the size of Jupiter, is traveling through the Milky Way at over 1,000,000 miles per hour. Oh, yeah. So buckle up, Buttercup. This is no joke. This is a discovery of a hypervelocity sub-dwarf star, could be a dark star, and it was observed while searching for Planet 9 through the Backyard Worlds project, which is a Planet 9 collaboration, including the Department of Astronomy and Astrophysics of UC San Diego, the Department of Physics and Astronomy, the University of Notre Dame. Major sell-off in the markets also. Do you got a 401 or IRA, or do you have money in stocks? You may want to jump on your computer real quick and take a look at what's going on. Robert Kiyosaki, Rich Dad, Poor Dad, warns millions of 401ks and IRAs will be toast. I've been talking about this for years, and I'm going to give you a happy recommend again. Check out Noble Gold Investments. You'll thank me later. Give them a call, 1-877-646-5347. Let them know Rex from Leak Project sent you. Go to leakprojectgold.com. Check out noblegoldinvestments.com. If you've got a 401 or an IRA and you convert into precious metals and qualify, find out how, you will be gifted either a 10-ounce solid silver American U.S. flag bar, or if you want, you can get the limited edition Trump rounds, 10 of these, 10 ounces, 10 single ounce rounds. And this is a limited edition solid silver. Don't let the money funders have all the fun. You know, money funders, the big banks, they're usurping tons of gold, literally. Gold and silver and precious metals, a tangible asset. Gold has been used to hedge against inflation for literally thousands of years. If you go back to the ancient Babylonians and the Sumerians, they were using gold and silver and precious metals as a form of exchange. So real quick, just jump on over to leakprojectgold.com, get your free ebooks, and go to noblegoldinvestments.com, call 1-877-646-5347, find out how to get your free coins, find out how to qualify, and subscribe to their YouTube channel, Noble Gold Investments. Right on, let's jump back to the podcast right now. California Institute of Technology, the Department of Astronomy and Planetary Science, Northern Arizona University. I have a long list of groups and bodies involved in this Planet 9 collaboration. So I don't want to read the comments about, oh, it's from NASA. You believe NASA? Like, that is the most common comment that I get in the comment section that attempts to rebuke or debunk this work. That's all they have. Oh, you believe NASA? Well, first of all, did you even read the article? No, you didn't. Did you watch the podcast? No, you didn't. You just looked at one word, NASA, and you've already got your own conclusion. Well, there's a multitude of bodies and people and personnel that are not under NASA that are describing this incredible discovery. So let's talk about it. Here's the paper. I'm just going to show you the paper here. Discovery of a hypervelocity subdwarf star brown dwarf mass limit, because it's 88 times the size or 88 times the mass of Jupiter. But as you can see right here, look at all of the people and the governing bodies, and wow, that's a lot of people involved. We report the discovery of a high velocity, very low mass star or brown dwarf whose kinematics suggested is unbound to the Milky Way. It's CWISE J124909.08 plus 3621116.0. Yeah. This was identified by citizen scientists in the Backyard Worlds Planet 9 program as a high proper motion faint red source. Moderate resolution spectroscopy with Keck Nyers reveals it to be a metal poor early L subdwarf with a large radial velocity, and its estimated distance of approximately 125 plus 8 parsecs yields a speed of 456 plus 27 kilometers per second, which is over 1,000,000 miles an hour in the galactic rest frame, near the local escape velocity for the Milky Way. We explore several potential scenarios for the origin of the source, including ejection from the galactic center in the past, survival as the mass donor companion to an exploded white dwarf, acceleration through a three-body interaction with a black hole binary in a globular cluster, and accretion from a Milky Way satellite system. CWISE J1249 is the first hypervelocity, very low mass star or brown dwarf to be found, and the nearest of all such systems. It may represent a broader population of very high velocity, low mass objects that have undergone extreme accelerations. Now, first of all, imagine an object 88 times the mass of Jupiter heading towards Earth through the solar system at 1,000,000 miles an hour. That's insane. I mean, that's like Planet X on steroids. When you had Farada and others project the speed of Planet 9 or Planet 10, Planet X, Hercobulus, the Nemesis. I mean, there's so many names for this alleged Planet X that makes a return. Now, if you want to link it to Nibiru, Nibiru actually means the crossing. If you break down the definition, the verbiage, is it a crossing of another planet? Was it a crossing of Saturn and Jupiter? Was it a crossing of Venus that caused Saturn and Jupiter and Mars and the planets in our solar system to go crazy and haywire and maybe linked to the Younger Dryas event, possibly? I don't know. But what's remarkable is the mass and the speed of this object. It almost makes me question, could this be like a look? They just had a dozen articles, give or take, recently, mainstream news articles about how scientists have potentially discovered Dyson spheres, up to 60 Dyson spheres. Yes, they searched millions of stars, but to come up with just one is incredible, yet alone a potential for 5 dozen Dyson spheres within several thousand light years. So now, independent astronomers and other astronomers connected with the Backyard's Planet 9 project discover an object moving at 1,000,000 miles an hour. Now, is that a bit alarming? And so they don't know what it is, but they think it's a planet, or not, I'm sorry, not a planet. They think it's a brown dwarf that was ejected from either a supernova or the core of the galaxy. What if it's a mothership? Like, what if it's a giant spaceship? I mean, I don't know, man. Type 2 civilization? Maybe it's been around for a very long time. This is talking about how they actually captured it, the technology and the equipment used, what they saw. Let's look at the orbit on this. The projected orbit of J129 plus 3621 from Galpy for 100 initial conditions, sampling uncertainties in distance, proper motion, and black lines. The top panels display the forward orbit over 10 GYR projected onto the galactic plane on wide left and narrow right distance scales. The bottom panels display the backward orbit over 150 MYR projected onto the galactic plane, which is on the left, and XZ coordinates on the right. The top left panel shows the present-day positions, magnetocrosses, and forward projected orbits, the magnetolines of 50 satellite galaxies, as well as the Milky Way's virial radius of 180 kpc. The dashed blue circle, the top right panel, shows the present-day positions of 161 globular clusters from Vasilyev and the closest approach radius of 1 kpc from the galactic center, which is the yellow dashed circle. Globular clusters and their backward projected orbits. The magnetolines are above, shown in the bottom panels. Take a look at that right here. Did you get that? Makes sense, right? As the bound orbits of J1249 plus 3621 extend beyond the Milky Way's virial radius, it is possible that this source could have an extragalactic origin, specifically accretion from one of the Milky Way satellites. Its present trajectory does not align with distant extragalactic systems such as M31 or the Magellanic Clouds. We examined the intersection of J1249 plus 3621's orbit with 50 Milky Way satellites using the same procedure as our GCs, integrating back to 10 GYR. Only one system, the Tucana 3, comes within 5 kpc of the median orbit of J1249, about 6 GYR ago. The substantial uncertainties of the trajectories of J1249 and the known dwarf satellites over GYR timescales means we cannot strictly rule out this scenario. However, we find it the least likely of the scenarios considered here, given the trajectory of J1249 being confirmed to the galactic plane. Inferring the true origin of J1249 will require further investigation into its physical and atmospheric properties. A galactic center origin requires closer examination of its orbital trajectory through refinement of its distance and velocity components, as well as a more realistic non-axisymmetric galactic potential model. A more detailed compositional analysis would also help clarify its origin. For example, if J1249 is the surviving companion of a type Ia supernova, its atmosphere may be enriched with heavy elements, particularly nickel, depending on the degree of mass stripping by the supernova blast wave. Similarly, if J1249 was ejected from the galactic center, a globular cluster or a satellite system, its detailed abundances may provide the chemical fingerprint of its origin. Better assessment of composition of through additional optical and infrared spectra and improved atmosphere models exploring specific abundances are needed to infer a chemical-based origin. Finally, we note that at least one other metal-poor subdwarf, ULAS J231949.36, has a high enough estimated tangential velocity to make it a promising hypervelocity candidate, although no RV has yet been reported for this source. The existence of at least one and possibly two subdwarfs within 200 parsecs of the Sun with hypervelocity speeds suggests a considerably larger population of such sources could exist in the Milky Way system. A lot of references. The Milky Way is approximately 300 parsecs. 1 parsec is approximately 3.26 light years, or 30.9 trillion kilometers, or 19.2 trillion miles. Let's go back and look at the observations that they're showing us this object. Low mass, hypervelocity star, 408 light years away. It's in the constellation Canis Venatici. Canis Venatici. It is an L spectral type, either a low mass red dwarf or a high mass brown dwarf. A speed of 456 kilometers a second over 1,000,000 miles an hour. It's near the local escape velocity of the Milky Way, and it was identified in the Backyard Worlds project by the citizen scientists Tom Bickel, Martin Kabatnik, and Austin Rothermich, now astronomer. The astronomers of the project observed the object because its motion and distance suggested a high velocity. The astronomers used NIRES on the Keck Observatory to take a spectrum of the object. The researchers also identify the ESDL1 dwarf, ULAS J231949, as an additional candidate hypervelocity star with a low mass, physical properties, and origin. The object has a distance of 125 parasec from the Sun, and its spectrum is SDL1, with SD noting that it is a cool subdwarf. The star has a high tangential velocity of 524 kilometers a second and a high radial velocity. In the galactic rest frame, this translates into a speed of 456 kilometers a second. It has an estimated mass between 83 and 88 Jupiters, which would make it a low-mass star near the hydrogen burning limit. The researchers say that this object does have a 10% probability to be a high-mass brown dwarf because the evolutionary model does not account for potential systematic biases for old low-temperature sources. Now, researchers are trying to figure out what caused this to travel, what is causing this to travel at 1,000,000 miles an hour. One possibility is that it originates from the galactic center. The object is currently moving towards the galactic center, so it could be on its return path. This is, however, only possible if it is bound to the Milky Way. Another possibility is that it was ejected during a type loss supernova. In this scenario, CY's J1249 would have been a type binary with a massive white dwarf, which would have involved mass transfer into a cataclysmic variable star. The predicted ejection speed for this scenario agrees with the speed of CY's J1249. Two other possibilities are that it originates from a dynamical ejection from a globular cluster or ejection from a nearby dwarf galaxy. There are, however, no globular clusters in the past position of this object. It is unlikely that CY's J1249 is an extragalactic star because its motion is confined within the galactic plane, which makes an origin within the Milky Way more likely. More research that involves a direct measurement of its parallax and additional optical and infrared spectra are needed to narrow down its origin. If it originated in a type loss supernova, its atmosphere could, for example, be enriched in heavy elements such as nickel in particular. Wow. Now, this constellation is one of the 88 constellations designated by the International Astronomical Union. It is a small northern constellation that was created by Johannes Hevelius in the 17th century. Its name is Latin for hunting dogs, and the constellation is often depicted in illustrations as representing the dogs of Bootes, the herdsman, a neighboring constellation. The stars in this constellation are not that bright. In classical times, they were listed by Ptolemy as unfigured stars below the constellation Ursa Major in his star catalog. Canes Venatici. Interesting how it's the hunting dogs, and they've got million-mile-an-hour objects, 88 times the mass of Jupiter, flying through the star system. Man, I can just imagine something like that heading towards Earth. Maybe something like that happened in the past, and that's why there's so much fear embedded in much of the population about this return of a binary star. This constellation is located in the northern skies in proximity to Bootes, Ursa Major, and Coma Berenices. Here's a star chart from 1825, the hunting dogs. Wow. Pretty intense, man. It also appears that you need certain technology to pick up this kind of star. A newly discovered rogue stellar body may well be a failed star, but it certainly isn't a failure when it comes to velocity. The potential brown dwarf is racing through our Milky Way galaxy at 1.2 million miles an hour. That's about 1,500 times faster than the speed of sound. Thankfully, this cosmic runaway is heading towards the center of the Milky Way and not towards us. However, the object is traveling so fast that it could eventually escape our galaxy entirely. CY's J1249 plus 3621 is its designation and isn't the only fascinating thing about the object. It's about 400 light years from Earth. Its mass is about 8% of the sun, 80 times the mass of Jupiter. It was discovered by citizen scientists working with the Backyard World's Planet 9 project, using data from NASA's Wide Field Infrared Survey Explorer to detect faint moving objects relatively close to the sun. Then they followed up using the Keck telescope, one of two 10-meter twin telescopes located on the dormant volcano in Hawaii. We discovered a very low mass object right on the star brown dwarf mass boundary that is an extreme velocity. Moving fast enough, it could actually be unbound to the Milky Way galaxy. Adam Bergesser of the University of California, San Diego told Space.com. It joins a collection of hypervelocity stars that have been found over the past few decades, most of which are thousands of light years from the sun, whereas this source is a mere 400 light years away. They say it also has an unusual chemical composition. The team aimed to use the information they gathered about the motion and composition to speculate on its possible origins. The original hypervelocity stars found about 20 years ago were massive O stars, about 50 times as massive as the sun, and B stars up to 16 times as massive as the sun. a likely selection bias because these stars are rare and would need to be found at large distances. Burgesser said, our discovery indicates that whatever process or processes causes these stars to run away must operate at both high and low masses. The star could have been kicked out of the center of the Milky Way by our supermassive black hole, Sagittarius A, a process commonly used to explain the origins of the hypervelocity stars, Burgesser said. Notably, our star is moving into the center, not away, but it might be on a return trip after being ejected previously. This is one of how many? The universe is so fascinating. These new discoveries are incredible, and the better our technology gets, the more we find, the more sounds we pick up from space, the more messages maybe, I don't know, maybe they're just cosmic pulses from stars and neutrino, well, not neutrinos, but magnetars. Within 10 to 20 years, we might actually be traveling the stars. We might be traveling the stars now, private sector, who knows, but I wouldn't doubt it. I mean, we look at UFOs now that they share with us that are supposedly aliens. You know, like look at that stuff from the 60s and 70s and look at the tech we have now. And it just, there's a missing link there. Something's missing. So buckle up, Buttercup. This is exciting. I want to read your comments. What do you think this is? Do you think that this is a brown dwarf star flying at 1,000,000 miles an hour? You think it's a spaceship? Think it's swamp gas? Think it's all just I want to read your comments in the comments section. I'm going to have an open mind on this. I think it's pretty cool regardless. And on that note, have a beautiful day. Hit the bell, be well, and be the change you want to see.